Hello again, and welcome to another AutoCAD Facecast here on Facebook. We're really glad you could join us. Today we have in our San Francisco office, straight out of Pittsburgh, our colleague John Twerdock. John, tell us a little about who you are and where you fit into this company of ours.
Sure. As I said, I'm from the Pittsburgh office, but I'm in the digital simulation group, so I'm the product manager for our digital simulation product line.
Digital simulation.
Yes, and simulation to us is predicting something before it happens, making a model of something and trying to determine how it's going to perform before you actually do something with it.
Okay, so we've got this audience here, it's really our AutoCAD fans. We've got over 1.2 million of them, and I really want to make sure that any conversation we have is focused on them. So how does simulation really support, or why should an AutoCAD customer, AutoCAD user, power user or not, care about simulation?
Well, clearly, if they're an AutoCAD user, they're using AutoCAD to build something, hopefully, to design and prepare something to be built. Rather than an old methodology, which is design it on the drawing board, go build a prototype and test it, they can use simulation as well to very greatly reduce their development cycles. And just because you're an AutoCAD user doesn't mean you can't use simulation. The simulation technology works well with AutoCAD, Inventor, all the way up.
Well, the simulation stuff that I've seen, I think of simulation as being really big. I've got a giant 3D model and I want to test wind, or I want to do finite element, and this seems like complicated. This seems...
It can be. I'm not going to lie. It can be. Sure, you can go as far and deep as you want. But there's great value in doing even simple simulations, absolutely, and in a 2D sense, right?
So 2D, you can get value out of a 2D simulation?
Oh, absolutely, absolutely. 2D simulation is where I would recommend most people start. I think a lot of users today jump immediately into 3D simulation before they understand the 2D model, and honestly, a 2D model will give you a lot of indication of what the entire design might perform like. So you don't have to burn a lot of cycles and a lot of compute time when you're running a 2D model. Those will run very, very quickly.
So those will run quick. But one of the things that we've been talking a lot about with our Facebook fans is Autodesk 360.
Yes.
And the fact that people are able to now put their data, their designs into the cloud, and be able to access them from iPads or from their mobile phones or from the web, collaborate, this kind of thing. So how does 360, how does the fact that we're now in this 360 world, how does that relate to simulation? How does simulation leverage that?
There's a couple of key ways. The power users, absolutely, they're gonna leverage this compute power that's available. But the average user can run many more simulations by using the cloud. So for example, if I was designing a very simple bracket and I wanted to look at 10 different alterations of that, I could run 10 simulations to find out which one carries the greatest load and run them all at the same time in the cloud. I don't have to wait. So rather than in the old days running things serial, one at a time, I could run them all at the same time. And now I could very quickly see my results and go, design C is the winner.
Okay, we had a gentleman, I think it was Stephen Hooper here before, and we talked about Inventor Optimization, where they were able to send it up to the cloud and run a ton of those simulations, I guess?
That's exactly what when you talk Inventor Optimization, you're using our technology from the simulation guys, right? That's our stuff.
Good.
And that's exactly what it is. It's running multiple iterations, and it looks for, depending on how you define the problem, I'm either looking for a minimum or a maximum, right? I'm trying to find, in most cases, I'm looking to minimize the stress or minimize the thickness of a part, because I'll save material.
So go through a couple scenarios, because I know there's certain, for the AutoCAD users, so what are a couple scenarios, use cases, workflows that you know?
Sure, well normally a lot of work gets done is maybe alteration on an existing design. Okay, a customer's called, they want something engineered now to spec, and it's, take my existing design but alter it for our specs.
A design of what? Let's get more specific.
It could be anything. It could be from a chair to a window to a bicycle part. It could be to a consumer goods part, something like that.
So mostly really in the manufacturing industry.
It's definitely
or building products.
It's heavily used in manufacturing. It's beginning to pick up a lot more use in the AEC space, so the architectural engineers are now finally adopting these kind of tools.
Right.
So we're seeing an exciting movement that direction with simulation for fluid flow. And by the way, when I say fluid flow, I'm talking like a simulation guy. But I mean things like the air in this room and human comfort. That's
so you can translate this for us.
Yes,
there's a lot of language around finite elements and
we're
fluid
engineers.
flow. Right.
Yeah, we use big terms to confuse the unwashed masses. That's what we do.
Good.
But when I say fluid flow in architectural space, I mean air mostly.
Okay.
Right? Mostly air. So airflow around this building, airflow in this room. What's the temperature distribution going to be like? Things like that can be predicted. So what would be the best place, for example, to place the air ducts in here so that they're not blowing right on the people here?
Okay.
We've done some incredible work with operating rooms, by the way, recently, where we're looking at...
in hospitals?
In hospitals.
Right.
And statistics are unbelievable. In the United States alone, over 100,000 people die per year from hospital-acquired infection. And that's a huge number. And one of the ways you can prevent that in an OR is to design an airflow that pure air passes once over the patient and is gone forever, does not recirculate, does not come back, and that's where most of the infection in an OR
so people are using simulation tools to get
to look at that.
Okay, that's great. So you used the word deflection when we talked previously too. What's that? Deflection
is how much is it going to move. Right? So if I'm designing, let's say, a bicycle frame, and I know that I can't have it deflect a certain amount, everything deflects. You might not see it with your eye, but if it's under a load, there is some deflection that's going to happen, absolutely. But you want to control that deflection, right? You don't want something interfering with another part, for example, which would alter the design. You can predict that, right? Interference between parts. One of the examples I'll show here is where we're actually trying to determine how much deflection will occur. There are times when you want to seal something together and you have to predict, did I make it deflect enough to make an effective seal under the pressure that I know that this thing is going to be bolted together. Very important.
So deflection, airflow, and then the other one you mentioned was mass, like being able to figure out how much material you need. What would you call that?
If you're doing optimization work,
yes,
you would like to know, can my design, how thin can I make that part and still take the load, right? And can I alter the geometry? If someone comes to me and says, hey, I like your design, but I need a hole right here to put a bolt, something else on. Well, I kind of like to know, does drilling that hole alter the stress patterns in my part, and if so, does it make it fail or deflect more than I want it to?
Okay, so I know you've got some stuff to show us. Do you want to start with this?
Sure.
Or you want to start with this?
We'll start with the iPad because it's kind of fun.
So what are you going to show us? What's it called?
This is just a model of what I would call them like the jaws of life. So if you look at a photograph I took here, simple jaws of life. These are the pneumatic devices that are used to pry people out of.
But let's start. What are we even looking at? What application? What is this?
Sure.
Where are we?
I'm in a free app called Force Effect Motion. So it's an iPad-based app, right?
Is it on Android as well?
Soon.
Soon. Okay.
It's right now on iPad. Force Effect and Force Effect Motion. This is Force Effect Motion.
And these are free. If you have an iPad, go to the App Store, download it, and here it is.
Exactly.
Okay.
Now this particular app, I took a photo of this, and I'd like to maybe design something similar to this, but what I'm most concerned about in this case, well, I need to size, of course, the actuator that drives this whole mechanism. I need to know where the hinges are, but when these open, I need it to open in a certain space at a certain rate. And so before I actually design something on, in AutoCAD, I may want to sketch it up here based on looking at an existing design.
So you're literally thinking about the geometry and the force relationships before you're doing the detailed design.
I want to validate my motion, especially the tip right now. That was what I was concerned with.
How easy was it to just place it? Is it like just sketching a line?
Absolutely. Okay. You can see I've sketched 1, 2, 3, 4, 5, 6 lines, put an actuator in.
All I see is lines in a picture. How is this different than just sketching something?
It's different because I've actually constrained this, and if I press this little button, you will actually see it. Now I can actually see it.
So you're actually applying the forces now.
Applying forces, I have an actuator driving this thing. I have the entire mechanism hinged, so you can see how this opens and closes. And I've defined that point out there as a trace point because I want to see how does that point move, how fast, and how it accelerates. So if I stop this for a second, and I can take a look, and I can open up a pretty cool little graph that plots for me at joint A, which is out here on the tip. I can take a look and find out how far it's traveled, and in what time. And if I want to actually close this, I can generate even a more detailed report by asking up here, just generate a report for me. And now you see, okay,
cool.
At trace point A, which was the tip of this, these jaws, I can look at the displacement, the velocity, and the acceleration as a graph, and then even get
a table.
A much more comparative
and you
table.
can bring that into Excel. So what's always interesting for the AutoCAD folks is how do I work with this in AutoCAD, right? How is this related to AutoCAD? This is great, amazing. I could be on the bus, I could be at home, I could, whatever. I could start to figure out and, play with the forces and the ideas.
To me, what's cool about this is now that I've got the motion I want, I've validated, hey, the velocity and the displacement's what I want. If I go back to my original gallery, I'll save it. And once I get back to my gallery in Force Effect, I have a little button at the bottom here that allows me to export this. I can either send the diagram by email to someone, but you can also read here. I can send it as a DXF.
Cool.
So now I've got the basic geometry nailed down before I start sketching it out.
Bring this in AutoCAD, and now I can do my good mechanical design.
I can get much more detailed at that. But I already know, hey, the travel at point A, which is what I was concerned about,
I can meet it. It's going to be what I want. That's
absolutely
great. That's great.
Very cool.
So this is just super simple 2D simulation that really helps you get. And you could do this for a building, for like an awning, anything that's structural related. It doesn't have to be a mechanical product like that.
Not at all. And what's nice about this is if I take a photograph and I sketch over it, all I need to do is put one dimension in, and everything else on my drawing gets scaled. So
okay.
I've had guys, I kid you not, use the application to figure out how to put Christmas lights on their house. They measured one dimension, and now my house picture's scaled up.
And now they know that they need 30 feet of X.
Engineers are strange. They'll come up with odd things. But in a design environment, if I just know one dimension.
So are you going to come out with a Christmas light app?
No, I have not thought of that yet. But there's a market for everything.
Okay, well, so that's the iPad. What do we have that's like more desktop that maybe works directly with AutoCAD or kind of next to AutoCAD?
Well, Simulation 360 is our current offering on the cloud. So Sim 360 is an offering that AutoCAD users could be interested in. It's a cloud-based application. It offers structural simulation, so you can do linear structural and non-linear structural, meaning one thing. Linear is I bend it and I let go of the load and it comes back to the same location. Non-linear is I bend it with enough force that it stays permanently deformed. You can perform vibration analysis on something to see how it will vibrate at certain frequencies. You can do thermal simulation, so you can do conduction, convection, and radiation to see how heat gets
transferred in the actual object.
Inside the part or around the part.
Okay.
It's picking up heat from alternate sources. And then finally you can do CFD, which is computational fluids. So it's the flow of a fluid.
So CFD is another fancy way of saying airflow.
It could be airflow, it could be water flow. You get to define what it is, depending on whether it's, in our terms, a compressible or an incompressible.
Okay.
Air is very compressible. I can put it into a container and keep putting more in. Something like brake fluid in your car is not compressible, right? You press on it and the pressure gets distributed all the way out to your wheels and it stops your car. So depending on the class of fluid, but we can handle both.
Okay, so what can you show us here?
Well, sure, I could show you an example here of just bringing what you do with AutoCAD. And this is a model, I'm bringing it into Simulation Mechanical. And you can see very quickly as we import the model, just go up and ask what I'm going to import. What do I want to bring in? I'm going to bring in a DWG file here.
Wait, so pause it for a sec. There were a lot of other files in there as well. So it's not DWG. You could bring in an AutoCAD file.
You could bring an AutoCAD, DXF, Inventor files. You could, if you so choose to use another CAD system, I don't know why, but you could bring those files in as well.
Okay.
But what I'd like, really what's interesting about this is a 2D model in AutoCAD, right? So it's a flange for a pipe. And what I was interested in was I have to bolt the flange together, right? That's what a flange is, two pieces of pipe coming together. And of course, what do I care about? I care about that sealing properly. So I want to take a look at this simulation and show you that I can import a 2D model here very quickly. Bring this in to Simulation Mechanical. And at that point, what I'm looking for is defining what is it that I really want to model. And because it's in 2D, it's easy for me to take this shape, which is what's called an axisymmetric image, if I take that 2D image and rotate it 360 degrees,
Right.
I've actually defined that part. But a 2D simulation is all I need to do. I need to tell the program, these are the pieces that I'd like to create. I generate a quick 2D mesh very, very quickly. You can see the seal there in the center. And then I go in and tell it, okay, what am I looking to do with it? Well, what I'm really trying to do is define some motion. So I will go in and say, I'm looking to solve this model. It's axisymmetric, so the program knows I'm going to rotate it.
The program knows it's right.
I'm only looking at a 2D slice. I impose a deflection at the top flange, and I force it down over that seal. And once I do that, I want to make sure that that seal contacts the inside there very, very well. So now I've solved this, and I can see here the stresses. These are called von Mises stresses. Again, big engineering term. But what I'm really looking for was, did I get a good seal in that area? So if we zoom in on it, you can see, well, we're not doing bad. We're probably touching about 80% of the surface here. I've compressed it sufficiently that that seal should hold. And I can see what clamping pressure that I have for it. And I can animate seeing that happen. And what's also interesting, once I've zoomed in on it, if I really want to look at this and visualize it in a 3D mode, I can actually go in and do that. So if I decide later that I'd like to look at this in 3D, you can see.
So it did the axisymmetric.
And now it looks like a real 3D flange. And I did all of that from an AutoCAD model. So I'm getting very valuable results without having to go to the great difficulty of creating a massive 3D model. I just took a 2D slice of it and did a very vital simulation, which is, what is my clamping force and deflection required?
And you put in the
scene?
materials of the.
Correct. You'd have to tell the program, what is this made out of?
Right.
Cold steel? Is it aluminum? Is it made out of a polymer or something like that?
Right.
So that's a quick example of how a 2D simulation could be very valuable. And again, that was not something that would require a huge amount of time to run that particular simulation.
No, that was an incredibly simple. Well, we're back again with our simulation in AutoCAD Facecast here with John Twardock. We just got disconnected, so apologize about that, but we are back and we'll finish. We just went through an amazing video that showed how a very easy 2D drawing could then be rotated into a 3D drawing, and that we could have a detailed simulation. That was great. Before that, we got an opportunity to see force effect motion, and taking an image and drawing a few force lines and some radius on it, and got to see it actually open, close, and understand that prior to the drawing. So the next thing that I would like to understand is how you, the Facecast participant here and our AutoCAD user, how you could get access to this technology to at least try it out, or where can you go to kind of learn more about this?
Sure. The place I would recommend, we have a website called the SimSquad, so it's www.simsquad.com, which is kind of the hub for our community of simulation users, right? Submit a question there. Hey, can you guys solve this kind of thing? Has anybody tried this? Does this work? That is kind of a community site that's answered by our internal SimSquad. We have a lot of simulation expertise here at the company, and we're allowing access. You can submit a question here. We filter those and send them out to the appropriate expert to get back to you.
So so you've got Meet the Sim Squad, you've got Simulation in Action, Simulation Resources, so people can come here and contact. One thing you had mentioned was this thing called Simulation TV.
Yes. Yes.
So what about this for the AutoCAD user?
It's really a great learning tool, and what I like about it is it's scalable, it's on demand, and you can go in here and look at a variety of topics, and it's kind of a fun way to see things. We've got numerous videos here, for example, on Simulation 360. If you want to learn how to get started and what the workflow is, right? For example, how would I start with my AutoCAD drawing? How would I import that into simulation? So
we're on here. So if we go to Simulation 360 Experience,
you can start there. There's also, if you go to Simulation 360, you can look at the videos themselves.
Okay, so come in here, Simulation 360. There's 7 videos.
Yep, and I think more toward the bottom you'll see Getting Started with CFD or Getting Started with
Okay, so here's Getting Started with Mechanical. That would be similar to the thing that we saw earlier.
Sure.
And then Getting Started with CFD, which is again the fluid flow or the airflow, that kind of thing. And both of these would be able to use 2D drawings, DWG files. So this would be a good place to go to at least start playing around with it. This is great because you actually get an opportunity to see the videos and stuff, but how can they get their hands on it?
if they want to get their hands on it, we are starting a trial. So Simulation 360 will be available as a free trial November 19th. We'll have a link right here on SimTV for it. In fact, if you look at the bottom of the player here, there's a little rotating banner there.
And if we go back to actually the Sim Squad itself, will it be on this page
Should be there as well, yes.
Okay.
A link to our trial. So
this is, if you go to www.simsquad.com,
yes,
you'll get to this page, you can get to the videos.
Yes.
And you said November 19th.
November 19th.
November 19th.
So very soon.
Trial, right.
Yeah, very soon.
And that trial will allow them to connect to the cloud.
Yes.
And to run stuff on their desktop.
They can. What they will do is they will download a client, which is in effect the software. They can play with it as much as they want on their desktop. When they're ready to run the simulation, it'll launch it up to the cloud and run the simulation. And then when it's finished, the cloud will just download automatically back to their account, and they can start looking at the results that they've got.
That's great. And Force Effect, they can go out and get today.
They can Force Effect today.
That's available today.
Available today. Yeah.
Okay.
Absolutely.
So if you've got an iPad or an iPhone right now, you can go get Force Effect.
Yeah, Force Effect is iPad only right now, I believe.
Okay.
iPad only.
But Android is probably coming soon.
Yeah.
Okay. Well, that's
so it's
great.
good. You know, I would again mention with SimTV, if you're really interested in simulation, you want to get an idea for what we do, that's a great place to go and just click around and watch some of the videos. We've got over 120 videos there now, and we're starting to even localize them in other languages because some of them have become popular enough that people are saying, please show us in our language. You'll see things there for the architectural community. You'll see things there for specific industries. You'll even see things there for our simulation of plastics. So if you're in the plastic, if you make parts out of plastic and you want to understand how that's going to flow into a mold, we have simulation mold flow technology that'll let you predict that process as well.
So this is once again another reason why it's great to go get your free Autodesk ID, right? So that you can log into any of these Autodesk 360 properties. We saw a couple weeks ago that you could get a trial of the PLM 360 software also with that ID. You can get now a trial of the Simulation 360 software and cloud services with that, as well as all the other great services you get with Autodesk 360. So I would highly recommend that you at least go out and get your 360 account, and then you've got this opportunity to start playing around with some of these really, really neat tools.
Sure.
So.
Welcome to have them. We'd love to hear your questions. So.
Okay. Anything else you want to say to our AutoCAD?
No, I think don't be afraid to try it. We've got a lot of hand-holding examples there. So if people have a little anxiety about doing simulation, we've got a series of problems that are there to support trial users.
Right.
Click on those and walk through those examples, and it'll walk you through the workflow and make you understand what you can do and how to set these models up.
Right.
And you'll be generating results very quickly.
All right. Well, thanks again for coming to this Facecast. We'll see you again real soon. Take care.